look at questions 4 and 6. We're going to skip 5. It's actually a chi-squared question. This question you could all do. It's a chi-square test of independence. It's just kind of where you're running down phantom and completing it, but it's not on the exam, so I kind of skipped over it. Number 4 is actually relatively easy. I was surprised at how easy this was. In part A, it wants us to talk about chemical Z and saying how the percents from the pottery pieces are similar and how they differ among the 3 sites. And so we're looking at chemical Z, and I've highlighted each of the 3 box plots. You could have circled them or whatever you wanted to do to kind of pull them out, make them stand out. Instantly, the first thing I noticed is that, wow, they're very similar in where their centers lie. It's about 7 all the way across the board. I also noticed that they were all very symmetrical in shape. But the big difference here is that this is extremely consistent in the results. It was almost always between 6 and 8. And this was really had a lot of variety in it. The spread was very different between the 3. And that's exactly how I approached the question. I said, for part A, I want to make sure to talk about shape, center, and spread, because it basically asked me to compare the distributions. And so I pretty much said what I just said earlier. I said that all 3 median values were consistently around 7%. The distributions were also very symmetric. I also said that the biggest difference here was that the spread was very different. I said that Site 2 had the most consistent results, while Site 3 had the most variation in chemical Z. So I made sure to talk about each one of these, and I made sure to use vocabulary that compared them together. They were all the same, or here is what they were different about. This was more, this was less. Make sure that you use those vocabulary words to describe your similarities and differences. That's a big deal. Okay, if we go back and look at question B, it had 2 parts to it. In part 1, it said, suppose that if you added up all of those chemical results, and they all added to about 20.5%, what site do you think that it would come from? Which sites, 1, 2, or 3, is the most likely site from where your pottery piece originated? In part 1, I took the approach of looking at the centers of each of my sites, right? I wanted to kind of take it, and if I look at the graph, I was trying to say, well, if I added up those middle values, right, for Site 1 and then Site 2 and then Site 3, I'm curious on which sum gets closer to 20.5. Okay, now while that's a good, that calculation is very relevant and definitely can get you to the correct answer, it's not completely consistent or not sufficient to answer the question. In this case, I went ahead and added up each of the sums, each of the median values for 1, 2, and 3. So I could see explicitly how they are, right? 1 seemed to have a very high average, 2 seemed to have a very low average, and 3, not average, but the sum of the medians. And these sums seem to be really close to what I wanted it to be. However, when I looked up the key, they wanted one additional thing to be done. And maybe you decided to do this. I simply did the first thing that came to my mind. It's just not completely, results weren't completely accurate. For one, they also wanted to know, oh, let me change that color. For one, well, for part 1 in section B, they wanted to know the minimum sum and the maximum sum. Okay. They wanted to know that for each of the 3 groups. And when you did that, it gave you, oh, here's the minimum and maximum values that this sum could take. And what you wanted to do was you needed to see which one did 20.5 fit within. And it was very clear that it was Site 3 that it would fall into. Site 1 seemed to have way too large of values. Site 2 seemed to have way too small values. But at what I wrote down in part 1, I would have only gotten partial credit for this. Make sure that if you did this one, make sure that you add the sums, the min and maxes of each one's, right? So you add all the minimums together, add all the maximums together, and that would have given you a much clearer picture of where 20.5 could have fallen into to get that full credit. Okay, part 2 is, it says suppose that only one chemical could be analyzed, X, Y, or Z, and I wanted to be able to identify that where it came from. And so if we look up at the chart again, I'm looking to see if I could only pick one chemical to identify which site it is, which one would I want. I thought this was really easy to do. I thought that chemical Y was the most different in each of the groups, right? They don't even overlap. Like this is really high, this is really low, this is right in the middle. So if I had known chemical Y only, then I would have been able to identify which part it came from, right? And I said we should ask, or we should look at chemical Y. It has the most different center. In fact, none of the box plots even overlap at all. This would give us a clear picture of which site pottery came from. And I would have given you the sufficient answer there. I need to make sure that I needed to tell you that it was Y and why I chose that it was the, well, I picked center, but I also made a point to say that it was because that they were so different that none of the graphs even overlapped, so that we could have determined which one it came from. So, and that's question 4 from 2017. Question 5. Here again, it's asking for an association between age group, right? Instantly, you're like, okay, two-way table, right here, right? I've got an association. This is definitely chi-square test of benefits, but it's not on the test this year, so I didn't want to waste your time and go over it since it's on Friday. Okay, this was a really tricky question, number 6. It had to do with probability, and I sat down with this, and I didn't clear up all of my work. Now, I did a lot of things here that, well, let me walk you through it. For part A, they wanted us to figure out if you flipped a coin, what's the probability you could get these different arrangements? And so I thought, well, if I'm flipping a coin, that made me think of a tree diagram, heads, tails, and things like that. Then I thought, well, I could do a simulation, and I pulled up my calculator and pulled up the coin simulation and just flipped a coin, or I could have done it with an actual coin. And I did it 8 times, and I was going to go in, I was going to write down each one, but I realized that I'm going to have to do it a lot more than just 8 times because there are a lot of ways that this can happen, and doing it 8 times really isn't sufficient. So I thought there's a better way to do this. So I went down and said, okay, let me just write down. So I looked at treatment A, or arrangement A. In order for this to happen, it has to be tails, then tails, and that's all that has to happen. Because if the 2 tails show up first, because they said here, it's going to be the man 1 is going to go first, the man 2 is going to go second, woman 1 is going to go third, and woman 2 is going to go fourth. That order is consistently done every time. And so I wrote it down here. Well, if I get 2 tails first, then I put X's for the rest because it doesn't matter. Then I said, well, how often can I get 2 tails to show up in 4 flips of a coin? Well, that's 0.5 times 0.5, right? The rest doesn't matter. So that's just 0.25, right? 1/2 times 1/2 is 1/4. And then I thought, well, what would arrangement B consist of? That would mean that I would get you can see that it's kind of small, but I would get tails first, then I'd have to get heads next, and I would have to get tails second, or third, I mean, right? So that would look like that second group, tails, heads, heads. The third one could have been tails. Okay, it doesn't matter what this is, because once I've got 2 here, this one's going to end up in the tails group. But there's 2 other options I could have chosen or flipped a coin and gotten, but it wouldn't have mattered. So what's the chance that these 3 things happen? So it's 0.5 times 0.5 times 0.5. We can use this 0.5 and the multiplication product here, the multiplication rule, because all these flips are independent. And so I went through and wrote it out. The only 2 that really matter are the ones where I get tails, tails first, or heads, heads first. Because if those 2 things happen, then it forces the other 2 parts to happen. So here I'm going to get a 0.25 and the rest of them, 3 are going to show up each time. And that allows me to see that it's 0.25. And what was important here is that when I had all of this, I made sure to add it all up, and I wanted to get 1. The part 2 said, okay, well, what's the chance that man 1 and man 2 ended up in the same group? So that would mean that you ended up in either group 1, which man 1 and man 2 ended up in the treatment group, or arrangement D, which man 1 and man 2 ended up in the control group. Every other place, they're in different sections or different groups. So that was easy. You found those 2 groups, 0.25 plus 0.25. So it was a 50% chance that man 1 and man 2 were going to end up in the same group. If I go on to the second page, this is where it kind of said, all right, the other option would be if we didn't do a coin flip, but we put chips in a bag and we pull the bags out kind of without replacement. And so I went ahead and I said, well, in A, what's the chances of that happening? In chance A, there are 2 chips that are marked treatment and 2 that are marked control. So there's 2 out of 4 chances that man 1 ends up in the treatment group. Okay, that leaves man 2 going second. There is only 1 treatment group left out of the 3 chips left in the bag. Remember that if man 1 and man 2 both go into the treatment group, doesn't matter what's left over, that's going to happen, and the rest of it is forced. There's not a chance that it happens. So it's a guarantee. So it's like multiplying by 1, right? It's guaranteed that woman 1 and woman 2 go into the control group. So we ended up multiplying. You get 2 over 12, reduces to 1/6. In arrangement B, I just carry that same process out. Man 1, there's 2 out of 4 chances. Man 2 going to control group, well, there's still 2 control chips left, but there's only 3 tokens total. So 2 out of 3, and then, of course, the woman 1 going to the treatment group, there's only 1 treatment out of the 2 left, and so that would be 1 out of 2 chances. Again, 1/6, or 4 out of 24. And I carried that process out for all of the other 4 groups, kind of taking it one at a time. D, remember, was the other chance that where both of them go into that, and it forces the second group to be pushed into that control group. So you end up getting 1/6 for all possible outcomes. This seemed to be a lot better choice because you ended up getting equally likely groups rather than the first chip or the first group with the coin. You ended up with groups that were unequally likely to happen. And so that kind of, in part 2, it asks again, what's the chance that man 1 and man 2 are assigned to the same group? Well, there's 2 out of the 6 chances, so only a third chance that man 1 and man 2 ended up in the same group in this case. Now, to answer the very last question, it wanted to know which of the methods were better. I thought they put a lot of content into this group that telling us that there were 10 and 6, and they wanted to have them equally represented. It really didn't matter. What you wanted to make sure to point out was that there's a greater chance for the students to be assigned to the same group in the first one, and the groups were not all equally likely. So it made it sound like the first option with the coin flip, it wasn't as useful, or you wouldn't have had a consistent result because you had unequally likely groups. So I said, let's choose the chip method because that method provides a much more equal chance that you get all the same group, or the groups that come out are all equally likely to occur. And for an experiment, that kind of keeps everything in, and I don't have any kind of confounded variables there. So we can kind of talk about which group seemed to have better results, and they were all equally likely to show up. This was a pretty challenging question for number 6. This is definitely lots more about probability. I don't think that you're going to see a full-on question about probability, not like this year is going to be. You'll probably have some probability, but it'll be mixed in with a lot of other topics. So hope that helped, and if you have any questions, please feel free to email me, and we'll talk about it.